Okay, our lesson that is on integrating factors. This is for differential equation. So, today we are going to discuss on some exact differentials. So, exact differentiation. So, if we will have a form of x dy plus y dx, that is equal to the derivative of xy. If we have a form of x dx plus y dy, that is equivalent to 1/2 derivative of x squared plus y squared. And then for number 3, if we have a form of x dy minus y dx over x squared, that is equivalent to a form of derivative of y over x. If we have a form of y dx minus x dy over y squared, that is equal to derivative of x over y. And then if we have a form of x dy minus y dx over x squared plus y squared, that is equivalent to derivative of arctangent y over x. If we have a form of x dy minus y dx over xy, that is equivalent to derivative of ln of y over x. Then, if we have a form of y dx minus x dy over xy, that is equivalent to a form of derivative of ln x over y. Then if we have a form of x to an exponent times y to an exponent, that is p minus 1, q minus 1, then times py dx plus qx dy, that is a form of derivative of x to the p, y to the q. So this is form number 7, form number 8. Okay, the next example we have our first example. Okay, we have our first example. We are going to evaluate x dy plus y dx equal to x squared y cubed dx. So this is now the form of the given. We are going to solve by exact differentials. So here, if you are going to look at this one, x dy plus y dx, that is a form of, formula here, x dy plus y dx, that is a form of derivative of x y. So therefore, that's the reason in our second line we have x dy plus y dx. We change that format into its new form, derivative of x y. That is from this formula. Okay, so from our given, we have x squared y cubed dx. So our du is equal to derivative of xy. That is our du. So we need u in the form also of xy. So in order to have an xy u, so look at this one. This is derivative of x, right? So if this is derivative of x, we are going to eliminate y cube. How to eliminate y cube? Of course, we are going to divide by y cube. So if we are going to divide y cube at this side, so we must divide y cube at the other side, at the left side, right? since that is raised to cube, so that you must be consistent with your exponent for your u, you are going to divide this one with x cube, yx cube, because your exponent for y is cube, so you partner that one with x cube, so that you must be consistent with your exponent, because your xy, then your xy, that is your u, and then your du is xy. So like this one, to solve for when you are going to find the integration of xy, so we have an example here from the formula u to the n du, wherein the formula for that is u to the n plus 1 over n plus 1 plus c. So example, our u is equal to, so the integral of xy dxy. Okay, that is the complete form, wherein your du, that is dxy, derivative of xy. And then your u to the n, that is xy. So this is your u to the n, this is your du. So u is equal to xy, derivative of u, that is derivative of xy. So if we are going to look at this form, this is now complete. We have u, we have du. When your form is u to u du, for example this one, u to the n du, you can now proceed to u n plus 1 over n plus 1. So that's the reason we will have x plus y here. Your n is equal to 1, so your answer is equal to xy squared over 2 plus c. So do it here. So back to our example, because our y has an exponent of 3, and to be consistent with your exponent for your u, you must also partner that one with an x with exponent of 3. Why we divide with 3? Okay, why we divide with x? We divide with x cube, so that you will have a form of u. The form of your u is xy, because your du is dxy. Okay? Take note for that. So once you will have that form, we divide this one with x cube, y cube, so we can cancel y cube. Then you will have, what remains is dx over x. So here, this is x cube, y cube, that is equivalent to xy raised to positive 3. If we are going to bring that up, that would become xy negative 3, right? So this form now, okay, this form, this one is u to the n. This one now, this is now your du. Okay, so this one, this is now a form of u to the n du. So if we are going to find the integral for this one, if we are going to find the integration for this one, integral of this one, that is u to the n du. That is a complete form. So all you have to do, if you will have your du already, you just add 1 over n plus 1 to your exponent. So therefore, you will have negative 3 plus 1, that is negative 2 over negative 2. The integral of dx over x, that is ln of x. Plus, okay, ln of your constant over 2. So that's it. And then, if we want to get rid of our denominator, we multiply everything, both sides, with 2. So multiply by 2, so you will have negative xy negative 2. Because if you are going to multiply by 2, this would be cancelled. Multiply by 2, what will happen if you are going to multiply this by 2? So you will have 2 ln of x. that is equivalent to ln of x squared. Okay. So that's the reason if you will have ln of x squared plus ln of c, that is ln of c x squared. That is the law of logarithmic functions, di ba? So we have here, that's the reason we will have ln of c x squared. So if you want to remove ln, so multiply that with e. So that's the reason you will have, if you are going to multiply this with e, so you will have a form of cx squared is equal to e raised to negative xy minus 2. So that is now the form. Okay, the next example, we are going to find the exact analysis for x dy plus y dx, that is equal to x negative 2, y positive 3 dy. Okay, right? So from our form, note that x dy plus y dx, that is equal to derivative of xy. So from here, that's the reason we represent that one with dxy. That is from the form. Okay. So you will have equal to x negative 2 y cubed dy. Okay. So if we are going to look at here, this is dy. Your variable here is y, right? So we are going to eliminate x. So to cancel x, because that is x negative 2, of course, what we're going to do? Okay. Yes, that's correct. We are going to divide that by x negative 2 so that we can cancel. And then, as what we have solved for number 1 a while ago, you must be consistent with your exponent. This is x negative 2. If you are going to look at here, your u is equal to, what is your u? X, y. So therefore, your du here, that is xy, derivative of xy, that is your du, your u must be in the form of xy. Okay, you must be consistent with your exponent. What is your exponent for x here? So to eliminate x, we divide that with x negative 2. So therefore, of course, you are going to divide with y negative 2 so that you must be consistent with your exponent. So x negative 2, y negative 2. That is the same as xy raised to negative 2. So here, we can cancel. What you can cancel? X negative 2, x negative 2. For y negative 2, if you are going to bring that up, this would become positive 2, right? Because you are going to bring that up. So if you are going to bring that up, so you will have y to the 5th dy. Here, if you are going to bring this up, this would become xy squared derivative of xy. So you have now a form of, okay, you have a form of u to the n du. If your form is u to the n du, so that is now complete. Proceed to integration. So this one is, unsa man ni? U to the n. Okay. This one is du. So when you are going to integrate this one, proceed to integration, that is u to the n du, so u to the n plus 1. What is your u to the n? So you will have xy, that is 2 plus 1, that is 3, over 3. That is equal to integral of y to the 5. So that is y to the 6 over 6 plus c. Because you have a common denominator here of 6. So that's the reason you will have plus c over 6. And take note, in our number 1 answer, we have ln. That's the reason for our c, you will have ln c. So here, we don't have ln, so direct with c over your LCD. That is 6. So to get rid of your denominator, that is your 6 as your LCD, what we're going to do? Of course, you are going to multiply both sides by 6. So that's the reason we have M6 here. Multiply by 6. So if you are going to multiply this by 6, so 6 divided by 3, we have 2. So 2xy cubed, that is equal to y6 plus c. Because if you have over 6 here, then then here, you will have LCD, so that will be cancelled out. So you will have, so that you will have a form of xy. Okay, if you will stop answering here, okay, that will be considered. So the simplest form, multiply with y negative 3, so that you will have a form of x and y variable. 2, then y. So here you will have multiply with y negative 3, so that's the reason you will have 2x cubed, because your y negative 3, your y will be cancelled, right? Then here, y negative 3, so y positive 3 plus c, okay, multiply with negative 3, so cy negative 3. So that is now your final answer. So we have here an explanation, okay, why I multiply here with why I divide here with y negative 2. Okay, we have here. So, as our review, we have the form of dxy. Okay, this one, dxy. Then we have a form of equal to x negative 2 y cubed dy. Okay. So, note here, your variable for your d here, dy, variable is y. So, if your variable is y, canceled out x so that you can proceed to integration. How to cancel x? That is, you are going to divide with the same what is in the given. So, x negative 2 divide with x negative 2 so that you can cancel out. And then, look at here. What is your du? Your du is xy. So, therefore, you must have a u in the form of xy. So you will have a form of xy. You divide here with xy, right? So, you divide here with x negative 2. Of course, you divide here with x negative 2. But then you need y. And you must be consistent with your exponent. So, kailangan pareho ka og exponent for your x and y. So, like this. So, therefore, what is your exponent for your x? Negative 2. So, you must also have an exponent of negative 2. So, x negative 2, y negative 2, that is also the same form as xy raised to negative 2. So, this one is your u to the n. And this one is your du. So, we have here the explanation. Why we divide y negative 2? So, answer. We need to complete u to the n. This one, u to the n. xy. Because du is equal to dxy. So, ang ato ang u is xy. Okay. So, dapat we have xy. That's the reason we divide with y negative 2. Okay? Y negative 2. Your y negative 2 is your exponent because you must be consistent with your exponent. Negative 2. Okay? Okay. The next example, we have x dy minus y dx equal to x squared minus 3 dx. Okay. So if we are going to look at here, the formula that we are going to use, that is x dy minus y dx over x squared is equal to dy over x. Okay. Because your given here is only x dy minus y dx, and then that is equal to x squared minus 3 dx. How we can have a form of over x squared? Okay. Because the given is we don't have a denominator of x squared. So, to have this, of course, we are going to divide with x squared both sides. Okay. So, when we are going to divide x squared both sides, so we now have a form of x dy minus y dx over x squared. And then here over x squared. If you have x squared over x squared, that is 1. Here, 3 divided by x squared, you will have 3x negative 2. Because if you are going to bring a positive exponent up, that would become negative. So here, because we have now completed the form x dy minus y dx over x squared, so you transform this one into this one. Okay. So that is from here. Derivative of y over x. That is equal to 1 minus 3x negative 2 dx. If we are going to look at here, we have single variable here. So we can find the integration. Here, we have the integral of du. So what is the integral of du? Okay, remember, the integral of dx, that is equal to x. The integral of du, that is equal to u. The integral of dy over x, what will be the answer? Okay, that's good. That is equivalent to y over x. Okay, so that's the reason we have here y over x. That is the integration of dy over x. That is equivalent to the integral of 1, that is x. The integral of x negative 2, that is x negative 1 over negative 1. Negative, negative, so you will have positive. Okay, plus c. We don't have LCD here, so therefore, you will have plus c. So therefore, you will have multiply cross multiplication x to the other side. So you will have y is equal to x squared plus 3 plus cx. Okay, that is now your final answer.